What if your doctor could treat the disease you're going to have 5 years from now today? We're talking about a massive shift in medicine, moving away from just reacting to problems and toward actually predicting them. And you guessed it, the tool making it all possible is artificial intelligence.
Seriously, just think about that for a second. A piece of software that can look at your entire health history and predict, with pretty stunning accuracy, what you might be facing in the next 5, 10, maybe even 20 years. This isn't science fiction anymore. This is the new frontier. All right, so let's dig into how this actually works, starting with you and we. The big idea is to have an AI that can read your health journey like it's a story, and then it starts to write the next few chapters.
Now, the concept behind this is actually brilliantly simple. You know how language models like ChatGPT are amazing at predicting the next word in a sentence? Well, some researchers had a light bulb moment and realized they could use that same exact logic for our health. Instead of predicting words, the AI predicts the sequence of diseases in a human life. It's such a simple shift in thinking, but it is incredibly powerful. And the model making all this noise is called Delphi 2M. It's built on what's called a transformer architecture. That's the same engine behind AIs that write text and create images, because it's just fantastic at understanding sequences. And its classroom? The UK Biobank, where it studied the health records of over 400,000 people. It learned all the complex patterns of how diseases progress and connect over an entire lifetime. So how's it do it? Well, first, it basically drinks up a person's entire health history, diagnoses, lifestyle factors, you name it. Then it arranges all of that into a timeline, a sequence. And this is where the magic happens. Based on that sequence, it calculates the probability of over 1,000 different diseases happening next. From there, it can even generate entire hypothetical health timelines, giving us a peek at possible futures up to 20 years down the road. And here's a perfect example of what that looks like. Let's say the AI has your health data up to age 60. It might generate a future where, at 68, there's a high chance you'll develop type 2 diabetes. And that might be followed by an increased risk for joint issues by 75. Think of it as a roadmap of potential futures, giving you and your doctor a chance to pick a different route and change the destination. Okay, but how accurate is this thing really? Well, when it comes to predicting one of life's most definitive outcomes, mortality, the model scored a 0.97. Now, in machine learning, a perfect score is 1.0. Getting a score this close to perfect is, frankly, astonishing. It proves that for certain really key outcomes, this model's predictive power is the real deal. So now, let's zoom out from the individual for a minute. Because this predictive power isn't just for you and me, it's also being aimed at one of the biggest, most expensive challenges in all of healthcare: developing new drugs. Just as a quick refresher, getting a new drug to the pharmacy is a long, 4-phase gauntlet. You start by just testing for safety, then you see if it even works. Then you have to compare it against what's already out there, and then you monitor it long term. A failure can happen at any one of these stages, costing billions of dollars. So, to tackle this massive problem, researchers built something called TrialBench. The easiest way to think of it is like the UK Biobank, but for clinical trials. It's a huge AI-ready dataset specifically designed to train models to predict the outcome of a trial before a single dollar is even spent.
And this isn't just one boring database. It's a really powerful combination of sources. It pulls public records from clinicaltrials.gov, gets super detailed with molecular data from DrugBank, and then adds even more info from TrialTrove. The end result is a complete, panoramic view of the entire clinical trial landscape. So what's the big payoff here? Well, with this data, an AI can start to predict things that, until now, were basically just educated guesses. Is this trial going to succeed or fail? Why might it fail? How many patients are likely to drop out? How many bad side effects are we going to see? This is all about de-risking the entire drug development pipeline from the very beginning. Okay, but with any powerful new tech like this, we absolutely have to ground ourselves in reality. These AI models aren't magic, they're not perfect, and it is crucial that we understand their blind spots. And you know what? The scientists who built Delphi 2M are the very first to admit this. This quote from their own paper is so important. They state right up front that the model also highlights the biases it learned from its training data. So what exactly does that mean? It means the data itself isn't a perfect mirror of the world. The UK Biobank, as amazing as it is, doesn't fully represent the general population. On average, its participants tend to be a bit healthier, a bit wealthier, and less diverse. So the AI basically learned about health from a skewed sample of reality. And that means a model trained on this data could be less accurate for people from different backgrounds, which is a critical challenge that has to be solved as this technology rolls out. So when you put all of this together, the personal predictions on one side and the big picture forecasts for medicine on the other, you can really start to see the shape of a new era in healthcare emerging. Ultimately, it all boils down to this. We are right in the middle of a fundamental shift. We're moving away from a system that basically waits for us to get sick to one that can anticipate our needs and act beforehand. We're going from just treating diseases to actively preventing them. And that is the incredible promise of these new AI tools. And that leaves us with one last vital question. This technology has immense potential to make all of us healthier. But as we build this predictive future, we have to consciously and actively work to make sure that its benefits, its foresight, its cures are shared equitably, creating a healthier future not just for some of us, but for every single one of us.